couple things I noticed. One is there's a lot of hardware available for everybody to leverage. And the second thing I noticed is it's not always obvious how to do that. So this is a really high-level overview of the board farms that are available. There's multiple ones, and how to leverage those as a member, both as a consumer or adding your own hardware or both. So I'm going to be going back and forth between between another screen with some, I'm not getting on the internet, that's for sure, or the Wi-Fi. So I'm going to be swapping back and forth. I'm going to sit down so I can kind of go through that easier as I show you these things. So the primary goal is to just give you guys a general awareness of these board farms and how you might be able to use them. And then secondarily, at the end, give you an opportunity if there's something you'd like that you saw that you'd like to learn more about, I can make sure and let the teams that are doing this know or be aware so that we can then have follow-on training or other things like that. So we're going to go over the types of labs we have and then the locations of those labs. Really the types, there's pretty much 4 board farms available in Linaro. There's kernelci.org, there's the server colo, or colos, there's the Lava Lab, and then I think you all heard on Monday, the Dev Cloud that's just come out. So this is just a quick map, kind of shows where they're at. So you can see that they're all over the world. As far as the kernel CI, you can see that there's actually 9 of them now distributed throughout Europe and some up in Seattle, North America. Some of those are personal. They aren't all Linaro employees even that have those. And so it's really distributed across the world. Also the Dev Cloud, which we just, was announced, it's got instances in Austin and Cambridge right now. Dave's Lava Lab is in Cambridge. And what did I miss? The server colo is also in Austin. You can see the pink over there is the fact that we're planning on extending both the Dev Cloud and the server colo over into China at some point in the near future. Let someone take a picture. Okay, I think he's got it. So first I'll just give a real high-level overview of each of them, and then we'll kind of get a little deeper into each one. So the kernelci.org, that board farm or lab is based on basically continuous integration testing, and it's an infrastructure to validate and upstream kernel trees, build and boot. That's the primary focus at this point, is just build and boot. The server colo, it's the one that was in Austin. It's a 64-bit server lab, ARM server lab. And it's available for both members and community, and you can go just check out instances, whatever you want. It's based on OpenStack. We'll get a little more into that. So you can just submit a request, go check out that hardware, run some tests, run some validations for a period of time, and then it just goes away. Lava Lab, that's the one that's a lot of our development is based on, and that's the primary lab for all the groups and members to do builds on. So it supports a lot of the efforts within Linaro. It contains various member hardware, and it runs our production Lava instances. And those boards, when they are at times idle and they're available to members and specific community people for access to run tests on as well. And it's qualified further with usage plans and test plans, so it's the next level from the kernel CI. And then finally the Dev Cloud, which is the newest addition, distributed ARM64 cloud instance. So I'll go a little further now into kernel CI. Again, as I shared a minute ago, its primary purpose is to validate upstream kernel trees on the various numbers of ARM hardware that's available. And it basically runs every time these trees are touched. So if somebody modifies the tree, it runs and verifies that it still builds and boots on a large number of hardware instances. And that, of course, from a CI perspective is very advantageous because it allows us to find issues early. It's, again, virtual across all 9 locations right now and growing. There is a lot of interest in others building this out. And it's architected to be extensible as well. So it's really easy if there's a 10th instance, another 10th lab comes up, it's really easy for the guys to be able to add that. And as I said earlier, its primary instance is for build and boot and to make sure that the trees out in the community are regression free. And if you'd like to know more about that, they're talking about extending it into having some richer testing. There's another follow-on BKK16-213 kernel CI beyond boot testing session. I think that's later today, so you might be interested in following up with that to get the next level. And it's not just Linaro. There's some personal instances. Kevin Hillman, for example, has one. Tyler has his own lab, so it's various. And then there's some companies that also bring these board farms up that are used there. Let me check something. I think I have a... Yeah, so just wanted to give you a look at, here's the instance of, or out on that link that's in the presentation, the sponsors right now, so you can see Kevin's, Tyler's, there's several others, Collabora. Those are the 9 existing labs at this point. Those are out there available on the site. It does support various test automation frameworks, but pretty much all of it now is leveraging Lava as the test automation framework. I think that's true. Every one of them is now Lava. Is that true, or is one of them, is Kevin's still? Okay, so there's one. Okay, yeah, so 8 of the 9 are Lava. And you can learn more on Lava. We'll show you that link in a minute. Again, types of tests being run, primarily pass-fail for boot and build. Kind of interesting statistics. It was just created this year in May, and now there's already been over 1 million boot tests that have been executed. 160 unique boards, 3 different architectures, 29 unique SoCs across all of these board farms. So it's gotten pretty big and doing a lot of adding a lot of value to the open source trees that are part of it. And some of the ideas of future tests that they're wanting to extend into, LTP, K-self-tests, and potentially someone could add their own even. I think I mentioned earlier also that it runs basically on a touch basis. If someone touches their tree, modifies it at all, it'll be grabbed automatically by kernel CI, and it'll then run it across all the applicable hardware that it can execute on. So this is a pretty interesting picture. I'm pretty impressed by it. It took me a lot longer to draw and figure out than I would first thought, but it basically shows how this lab looks. And so you can see that there's a Jenkins instance running out on Amazon Web Services, and you can see how it's it's monitoring upstream trees and kind of the order of events over here in blue. When it is notified or finds that there's been a changed tree, it goes and grabs it, and then over in Germany, we actually have a server farm. So Amazon Web Services will pull that tree that's been modified, send it down to get built down in the board farm, and once that's successfully built, it'll publish that down into what's called kernel CI backend, and then comes all the way back through here to number 5, where a job is submitted to all of the available servers or labs, Lava Labs, and it'll run that instance. So it'll perform the tests once it gets the job. Of course, when it does that first, this side, the Lava Labs have to go over through this kernel CI API. It requests to grab what was successfully built, it fetches it, it performs the tests, and then it brings the results back into this backend database. And then finally, if a user wants to see what has been built, this is the dashboard where it gets pulled up. And I think I have a bigger example of that. Just one second. Yeah, there. So this is kind of what the dashboard then ends up looking like for one instance, showing how many total boots have gone through, the pass, fail, and there for people to analyze and see if it's booting successfully, and if it's not, be able to go out and figure out what's broken. And then this is just, I call it an API. It's not really, it's just showing from the previous picture where we have the Lava API, how Jenkins is using distributed builds to do these builds. The kernel CI API is leveraged. All of these, this page gives you the pointers to all of those if you want to learn more about them and be able to extend this. So getting involved. There's multiple ways to get involved. As a supplier, if you have ARM boards that you'd like to get put into one of these labs, you can go to this frequently asked questions page, and there's contact information there where you can, basically tells you where to send your boards, and the labs are more than happy to add your platform to the farm and get it built in there. There's also the harder way, and that's that you can create a whole lab. The build and baseline team very willing to help people set that up, and so you can start that process as well. If you want to add, you can also just add another tree. You have to be willing to support that tree, but it is possible to just request at this link, info@kernelci.org, if you'd like to add an additional community tree that you'd like to get tested in here. And another way is just actually get into the development portion, which is contributing actually to the Lava development. And there's some links here as well that help you get started there. And there's a Freenode channel, kernel CI, out there, #kernel CI, that you can get involved in as well. This gives you some links to the wikis. So a lot of information out there that is available for you to start getting involved in that. And then after kernel CI, we have the Lava Lab. The Lava Lab pretty much works the same way. It's leveraging this same infrastructure as kernel CI. It's just a little more intense on a bigger scale and does a little more in-depth testing. So it's responsible for providing a lot of the Linaro member automated testing that's going on for each of the engineering teams and is leveraged by all the engineering teams. Let me see. Yep, central development lab for the hardware that's being used by the Linaro engineering teams. You can get visibility of that through validation at linaro.org. I think I have that. It's got over 180 boards available, and you can, this link shows you, you can kind of take a look at those boards. Let me show you that. I think I have that. Yeah, so here's the entry point for that, and then it looked a lot different when I didn't have the low screen resolution. But you know, it gives you the entry point in how to actually start leveraging the Lava Lab with lots of instructions. And the other link on there was the devices that are being leveraged by the Lava Lab. You can see the devices on this page. I think it said 180 of them on my slide. Let's see if I was right. Yeah.
Because of the way we use one particular device type, it's about 8,500 devices.
Oh, really?
But most of those are retired devices. They're ephemeral devices that get created and then destroyed.
Oh, okay.
Just VMs, dynamic VMs.
So there's actually more than 180, you're saying?
Yeah, but it's a technicality.
Okay. So you can see there's Juno boards here. Here's some Qualcomm boards that are active in the lab. Number of different platforms that are being leveraged right now. There's a Dragon board that's been talked about this week. There's some Huawei platforms, TI platforms, so you can just see lots of hardware in there. And those, again, are doing more than just, in the Lava Lab, doing more than just the build and boot, but they're actually, you know, there's usage plans, test plans, per project, per engineering group. Each one has its own instance of tests that get validated. So how can you leverage the Lava Lab? Those, even though those are being used by the projects, it's possible when boards are idle that developers can get in there and actually check out a board and run some tests on it as well. I think I have that. This is showing. Yeah, this hacking session right here. So that's the terminology that it's been given, is if you want to go check out a board and run your own tests, create your own jobs, test jobs, you can go to this site that, you know, tells you how to create these hacking sessions.
So, just to be clear, you can either run completely automated tests, you can define an automated test definition, or if you want to get into a particular image, what Lava will do, you specify the image you want, the kernel will route.
Okay. So you can select your own image for that board to run, or you can just run the stock.
No, it will always deploy an image. Lava always deploys the image.
Right.
Not whatever's on there, because whatever's on there could be random. So it deploys to it, then it gives you an SSH access onto that image.
Right.
So you can then do anything you like in that image. But typically, you want to go for an automated thing, so it just goes, because hacking session has a timeout.
Right.
I want it for 3 hours.
Yeah. So the hacking session has a timeout, and you do SSH into these boards per the instructions in there. And to be able to get to them, you have to be able, you need to send an email to automation@linaro.org to ask for permission, job permissions, to be able to get in to use the lab. That's really, you know, one of the restrictions is they aren't just going to let anybody jump on there. You have to be able to, you know, identify yourself and get permission to use that. And of course, as a member, you can also add platforms to the Lava Lab. And this talks about how to do that. Those can end up being out on the linaro.org downloads page. So I think it's important to note, too, that you can add boards in there that have restricted access. So, for example, If you don't just want everybody being able to jump on your particular hardware, you can restrict access to those. And to request how to get the hardware, how to get your hardware into there, there's another site, CI Bring Up. Let me see. Right here. It's awful big. Anyway, this is the process for adding new build board process to the Linaro CI loop. So the link is in there if that was something that you were interested in doing. Next is the ARM v8 server cluster. It's often called the Colo. And back in that picture, that was the one that's in Austin, looking to be extended. Is that in Cambridge now too, or is it just in Austin, the Colo?
So we actually do host hardware outside of Linaro production. And we also have, as you said earlier, one of the nodes of the development cloud.
Okay.
One node, it's a lot of hardware. But,
Yeah, okay.
So yeah, we are implementing a similar or the same booking system as the Colo does for some of the hosted hardware.
Okay. And so this is also available for use. This is again ARM v8 server level. The one that was in this picture here is the one in Austin. It was built out just last year, and right now has a number of APMs and AMD platforms, 50 APMs. So and then it creates, hundreds of instances that you can check out. So this is the page where if you were interested in being able to check out, you can check out 2 platforms, you can check out 10, depending on what kind of tests you wanted to run, and you could then download. It basically creates a private session for you. You could make them all Ubuntu. You can then, if you want, install your own OpenStack instance on them, and kind of do a mini deployment, do some validation. So you have to fill out a request to do that, and then they usually check it out. You get it for 2 weeks at a time. It's private. It creates it. When you're done, it just blows everything you were doing away, and it's just gone. Okay, so it's got Ubuntu booting on U-boot. It's got Red Hat booting on UEFI. So depending on what you're wanting to do, you can also request Metal as a service out of there, and some examples of how it's being leveraged today. The Debian project is actually using 3 of these servers for their native ARM64 builds for Jessie. So it's already being integrated in pretty key for the Debian 8.0 64-bit support. It's been used a lot for ARM OpenStack validation by the LEG group. Of course, now that the Dev Cloud is coming out, that's going to start moving over into that. It's been used for Ceph validation. There's even been some researchers testing and porting server applications and validating them and doing verification. And there's another session available on that as well later on. ARM v8 server labs using users birds of a feather this week too, if you're interested in that and seeing what they're doing. And the Node.js project has leveraged that as well for some ARM64 releases. A couple blogs that you can look at that talk about the lab, and those are available in here if you're interested. So how can you leverage that? We've kind of touched on it, but members, you can apply for access. I already showed you the page where you can do the access request. It is for Linaro members and non-members of Linaro out in the ARM community can use it as well, but of course members have priority. I mentioned that it was private access, so you know when you get your servers, they are yours, and no one else can get in there and see them, and you do whatever you want, and then when it's done, it just gets destroyed and waiting to put another instance out there for someone else. No cost. Also includes what's called a control node. So if you get two servers, you'll be able to SSH into them, but you'll also be able to get into the control node that can do power on, power off, gain access to a serial terminal there and everything. So, and as Dave was saying, is SSH into the. So the restriction is, port 22. And then what's next? The developer cloud, that was, George talked about that yesterday. And that's already starting to get leveraged. Hopefully everybody's uploading their photographs to it this week to win a prize. It's an ARM64 server deployment for the purpose of evaluating, developing, and maturing ARM-based clouds. And again, there's been multiple members that have already donated into that. There's currently 5 members, 20 physical systems to date. It's located in Cambridge and Austin, and it's starting out with about 200 guest instances. And it can also it'll be providing people feedback or metrics on there. So if a provider provides some servers into it and creates their own instance, they can then evaluate how well it's been working and get the statistics that OpenStack gives you. So leveraging that, there is a lead project that's going to be using it. OpenStack is the management tool that's being used to be able to provision instances. And developers, ISVs, and third-party software developers for porting, debugging, validation. We really want to start putting a load on that and using it as though it's a production instance to be able to get it really solid over the next, what did they say, 1 to 2 years so that it's ready. Starting out with CentOS and Debian. Yeah, and of course your guest instances, you can put whatever you want on there. Security considerations. We are wanting to push for individual data centers so that those can be federated, but they can also be isolated so that if a company even wants to create their own data center, we'll support that. You can have your servers. They don't have to be in one of our locations. They can be in your facility, but still federated into the overall cloud. And that gives you physical security. And then, of course, you can leverage OpenStack and LDAP and for instance security and authentication. So again, to get involved with this one, the idea is to create individual data centers to extend it from hardware providers. Our team will volunteer to help set those up even for you. If it comes down to it, we can provide. They're already building the solution so that it'll be really easy to provide the bits to be able to extend it and include it as part of the cloud, the dev cloud. And it can be set up so that you do have those isolated test cloud instances. The way to get involved in that, here's the email address, devcloud@linaro.org. There's also a few websites here that are talking about it. You can monitor the 96boards.org developer cloud, and the request, just like we saw earlier for the server colo. A similar page exists at linaro.cloud. Okay, so any questions from anybody? And then also, I'd be interested if there's things that you saw in there that were interesting that you might like to know more about in the future. Quiet. Okay. I'm sorry? Yeah. Yes. Exactly. Correct.
So, Lava is the answer to that. Lava is an unbrick device. It's completely automated testing framework. So if your image crashes the device, we actually have remote power control. We can reintercept, move over, we can do all sorts of things. And it's not a problem. We always have a recovery.
And so there's multiple instances there too, right? I mean, one is if you're on an embedded board that's in the Lava Lab. Another one is the server colo, where you've, built up a server and you've got all that, and you also have the ability to reset that as well.
Right, but in server colo, basically you request, I want a CentOS, I want Red Hat, I want Debian, I want whatever.
Mm-hmm.
And then you just get given that. You can't deploy your bespoke image at the code.
Oh, right.
So
Okay.
with Lava, you set up a job, you specify where the image comes from. Lava will deploy that image, boot into it for you. And then if it all goes horribly wrong, Lava will recover it. So you submit a job. The job is fit for Lava.
Yeah, so the details are in there, but yeah, he's talking about it uses JSON, and you basically,
You specify the job control,
right.
i.e. what you want to deploy, and then you specify what tests you want to run. So JSON is the job control file, and then you have a YAML file which defines the tests you want to run and how you want to run them, and then also specifies how you want to interpret the results. And that's the way Lava does it. Yes, all the logs are available, a full serial console log, everything there.
Right. Yeah. Sure. If you want to add hardware to kernel CI, is there a minimum requirement to that? I don't think so.
So one of the things is if it's a board that is power controlled, because you've got consumer grade devices like phones, which the only access you've got is ADB or fast boot. But if it's a power controlled device, the only requirement is that if you power it off and power it back on again, that it auto boots. You don't have to press a button. Okay, that's the fundamental requirement.
I'm sorry, what was the question?
Is there any setup documentation?
Oh,
There's lots of documentation.
yeah, so a lot of the links in there, I had a whole bunch there, but there's a lot of information on how to set these up. And the links are in this presentation on doing a lot of that. And there may be questions, and there's also, ways to ask. So.
Yeah, I mean, in the first instance, if it's a lava installation, you're talking about CIU, and you talk to Mead, and you talk to Fafi Boudra, who's the built base manager.
Yeah, so it's totally possible for you to leverage the technology that's been developed for your own lab if you wanted.
There are, to my knowledge, there are 5 companies outside of Linaro, who use lava.
Yeah, so a lot of work has gone into building this infrastructure, and you can take that and leverage it and make an internal, emulate this internally in your company and build one that then you have plenty of security. Yeah.
And that's why some of Linaro's members actually have their own private instances, because it's early hardware that they don't want to hang on the building.
Right. But again, that if you leverage what these guys have already put together, which is pretty impressive, I think, you can then not have to go reinvent it.
Yeah.
One of our mantras.
But it's all open source. You just download it and install it. It's a package. I mean, Lara's package nice app to get installed on.
Oh, perfect. Any other questions? Anything here you'd like to see more about? The four what? So yeah, they have different purposes, different instances, and I doubt the dev cloud is never going to converge with our kernel CI that's full of embedded boards. There could be little 96 boards in there, so those are never going to converge. The server colo could, I'm guessing, I mean, it could eventually become part of the cloud project, but there's also, so there's also instances where somebody might like, so, the idea, and I think George even mentioned it, he envisioned that the dev cloud might live for 2 years as everything gets matured. So, as long as people are leveraging them, and we do monitor that, I think I mentioned the server colo has about 50 servers in it, and as long as people are checking those out and leveraging them, we know we're getting good value out of it, and that's monitored. So as long as people are taking advantage of these things, I think they will continue to live as they are. If, for example, the server colo, everybody quits using it, it'll probably go away.
But the overarching thing is that there's lots of things that are tools that we are using within Linaro to do our testing of various forms. So there's, of course, the kernel bootloader testing.
Right.
Does it boot? Yes, tick. And there's also power management working group do their testing, and the toolchain working group do their testing, all using different bits and pieces of what Don's been presenting here.
Right.
Just so they're all put together in different ways. It's quite there's a lot to get your head around.
Yeah, it is. Yeah, so this was the very top level. Okay, good.
We're planning on running a 2-day lava and testing session at the Let's Connect.
Yeah, basically a training. Yeah.
So that will go right into depth of how you get
Right.
set up kernels, the CI
So if that's of interest, Next Connect, they're planning on a full 2 days of really digging in, even having a platform.
Oh, we will have a server that you can deploy on,
Right.
test devices that you can actually do the whole thing.
Right. How about you in the back? Do you have any questions? He has one of the 9 kernel CI labs, so. Okay. Oops, one more.
I have set the Lava environment locally, and I want to run testing. Can I connect the Lava through PC and my phone connect to my local PC and use the Lava server to test the cases? Are this okay?
To test the phone?
Yes.
Yes, we actually do have phones in Lava.
Right.
Lava Lab.
And I have another question. If I want to add my device to Lava server, what should I do?
Sorry.
If you want to add your device into one of the kernel CI labs, or to get it being taken care of by, is that what you're meaning? But into our Lava or into your own instance?
So if you go to the validation.linaro.org website and go to help, it tells you all about setting up. There's a help button on the top line. It gives you all the information about installing, deploying, creating device types, integrating the device into Lava. There is a Git repository that contains all of the device config for the Lava Lab, the Cambridge Lava Lab, which shows you examples of how to integrate a device into Lava. Most of it's done through configuration.
Right here. This is, that's the API help.
Yeah.
You said help, right?
So go to help.
See if I can get it. I don't know if I'm even connected at the moment.
Dots the button at the top right.
Oh, where? Oh.
There. One says help. There you go.
Yeah, so was there any specific section you were talking about?
We could go down a real rabbit hole here. 'Cause
Yeah.
It's such a huge topic. I mean, Lava's a very big thing.
I haven't read this before, but I want to add my phone into your server.
Into our server,
Yes.
right?
I have tested for locally.
Oh, okay. Right, so you have integrated.
Yes.
Okay, well, yeah, I mean, as Don was saying, member hardware, people provide the hardware, we integrate it into the Lava Lab and make it available.
Yeah, so depending on where, again, if you want to put it in kernel CI, the presentation that is available for you to download has the links on how to put it in Lava CI.
I can provide we can provide the source code. And because we have built it automatically through the server,
Okay.
everything automatic.
Well, why don't we talk about it right afterwards, and maybe we can point them to the right place. I think that works. Okay. Anything else? Any other questions? All right. Thanks for coming. Don't sneak off, Dave. Let's see what he's looking for.